These first two here, they're from the 1.5 degrees C report, the most recent report, 2018. And SPN means Summary for Policymakers, and that's important because it means that this particular science has been scrutinized and approved by all the world governments. So there are two representations here from the 1.5C SPM. This is a stylized version of Global CO2 1.5 degrees C report addressed carbon dioxide. Global CO2 emissions pathways up here, so higher emissions on the vertical in billion tons of carbon dioxide per year. And you'll see that CO2 emissions decline from 2020, and they decline rapidly. IPCC on this image has two projections. This one for zero emissions by 2055, and this one more rapid emissions zeroed at 2040. Obviously, the IPCC is implying that we could and should go for the 2040 zero. This one here, this is the best case scenario in the 1.5 degrees C assessment. It's called P1. Gray is the fossil fuel, so that's fossil fuel CO2 emissions, and the land, the smaller area here, is CO2 emissions from land, notably deforestation, of course. Emissions in gigatons of CO2 per year again, 2020. The IPCC anticipated that emissions would continue to increase as they have done, and at 2020, so on an immediate basis, you see emissions have to go into decline, and they have to decline rapidly, and they have to be zeroed by 2050. This is the last full assessment of the IPCC. This is the best case scenario, RCP 2.6, the only scenario which does not lead to a global surface warming above, or may not, above 2 degrees C by 2100. And as you can see from this graphic, emissions have to decline fairly rapidly here from 2020, not as rapidly as we've just seen, of course, for the 1.5 degrees C report, because this is 2 degrees C, which we now know is total catastrophe, and it's only by 2100, which means that it's going to be higher than 2 degrees C after 2100. These are annual total emissions. So the IPCC 1.5 degrees C focused on CO2 emissions. This is CO2 equivalent, which includes the other greenhouse gases, notably methane and nitrous oxide. You'll see that there is a substantial reduction here by mid-century, but for never mind. You'll see, as is the case for all of the projections, that for stabilization of the global temperature and for ocean acidification also, emissions have to reach virtually zero, or as the IPCC 2014 assessment said, near zero. This is a very important one. This is back in 2007. This is the IPCC fourth assessment. And this is a projection for 2 degrees C at equilibrium, not 2 degrees C just by 2100 as we've just looked at, but this is for 2 degrees C at equilibrium, which occurs long after 2100. And in this case, you'll see that emissions had to be declining by 2015. By 2020, they had to have been on decline for a few years, making 2020 clearly today's deadline.
This is the global carbon budget, which is put out every year by the Global Carbon Project. This is the last one, December of 2018. This is fossil fuel CO2 emissions, and it runs from 1980 up to 2060 here. You'll see that there was a flattening of the emissions increase from 2014 to 2015, but in 2017, global CO2 fossil fuel emissions increased, and they increased again by a large amount, nearly 3% in 2018. So that line there is the worst case scenario. So you can see that we're tracking very, very close now to the worst case emissions scenario. By that I mean the worst case that the scientists thought would be plausible. This is from Climate Action Tracker. This is a group of climate experts, and they do the very valuable job for us of analyzing where we are headed with emissions. That is with the plans, with the national emissions targets of the governments, the world governments, and they also project where we have to go with our emissions, and it's no surprise that emissions have to decline rapidly from 2020. They give the 2 degrees C and the 1.5 degrees C consistent emissions.
This is the UNEP GAP report. UNEP, the United Nations Environment Program, issues a GAP report every year. This is the last one, 2018. And the GAP refers to how far off we are with the combined national emissions targets, how far off we are to climate safety. And of course, we're headed in exactly the wrong way to catastrophic planetary danger. Anyhow, we're looking at when emissions need to decline, and again it's 2020, and that applies to both 2 degrees C by 2100, as is shown here, which nobody is going for now, of course, and the 1.5 degrees C target, which is a 2020 peak and decline with a very rapid decline, headed fast towards net zero by 2050. Or in this case, a little bit after 2050. This is a very interesting and I think very useful research paper, the team led by Johannes Rockström, and it's a paper for rapid decarbonization by the proposal of what they call the carbon law. And the carbon law is simply reducing emissions by 50% every decade, every subsequent decade. And the result is approximately the same as the IPCC's rate of decline of emissions, declining 50% from today by 2030. So this is CO2 emissions, again in gigatons per year, and again it comes to zero by 2050. This is a very authoritative and special assessment which was done by the United Nations Climate Secretariat in 2016, a follow-up to the Paris Agreement. And the Secretariat calculated, and it must have been one heck of a job, the aggregate of the updated INDCs, that's intended nationally determined contributions, which simply means voluntary national emissions targets. This is in CO2 equivalent per year up on the vertical, running from 2000 to 2030. The emissions targets had been arranged that they would run to 2030. So I have kept in the projection here, and as you see, the combined emissions targets keep emissions increasing, and by 2030 they have substantially increased, and they're still increasing at that. Now we have a 2 degree C, what they call least cost pathway here, and the 1.5 degree C pathway here. I've marked 2020 as usual, but this is 2015 again. The emissions peak here soon after 2015. They're in, and they should have been, in rapid decline by now. This P1 is a notation for the immediate mitigation scenario, which has a better than 66% likelihood of staying below 2 degrees C by 2100. So again, this will give the impression of really how terrible and dire our situation is. Clearly, we're overdue for a rapid decline in emissions, and 2020 is the absolute very latest that the world can wait for literally a chance at survival. This one here is from the International Energy Agency, and they produce regular reports that do involve emissions of fossil fuel energy related carbon dioxide. They do this in special reports as well as in the annual World Energy Outlook, and this is the Energy Outlook for 2016. IEA makes the point that there's still a long way from a pathway to energy sector decarbonization, and the current pledges fall far short of limiting to 2 degrees C. And this is the 2020 decline, and these are the current the IEA calls them the current pledges, and again substantial increase by mid-century 2050, going in exactly the wrong direction, suicidal direction rather than the direction of relative safety. Emissions decline again by 2020, and because this was only 2 degrees C, zero is soon after 2080 by 2100. This is Climate Interactive. This is a website and a number of projects under the climate experts, approved and checked by the climate experts, and this is their scoreboard. And this one was published in 2016 again. This is global greenhouse gas emissions. The vertical axis runs from 2000 all the way through to 2100. And the emissions decline in both of these scenarios of the Climate Interactive decline at 2020. This one, the estimated 2100 temperature is 1.8 degrees C, so this is the 2 degrees C one basically, and this one with the faster decline is the 1.5 degrees C. So we've known for a significant number of years the big difference between 2 degrees C and 1.5 degrees C, both in how much we've got time left, which is nothing, and how fast emissions have to decline, which is very rapidly. And thanks to the IPCC, we know the huge difference in disastrous impacts and planetary catastrophic impacts at 2 degrees C. This is a scientific research paper published in 2016 by Rogelli and colleagues. greenhouse gas emissions, so CO2e, and I simplified this obviously, just taken the mean lines. In all cases, the emissions decline by 2020, and this was for a 2°C scenario. And the name of the paper was the Paris Agreement proposals would have to be improved considerably. That was something like the title of the paper and certainly the gist of it. So another research paper telling us the same thing. This one here is from The Economist. Again in 2016, The Economist says global greenhouse gas emissions forecasts in gigatons of CO2 equivalent for less than 2°C and for less than 1.5°C. And as you see, the same thing. 2020, in both cases, emissions have to decline. For the 1.5°C, they have to decline considerably rapidly, more rapidly than the 2°C, and they quite definitely can. This definitely can be done.